Alright, so hi guys. So this is another Kirchhoff's law video. So this one of course is from the CAPE Unit 2 Physics Study Guide, and it's on page 26, question 19, right? So of course A is basically in the book. It's saying state Kirchhoff's law. So that is on page 15 of the book, but in relation to the working out. B, let's start. So we have currents IA, IB, and IC, and they're saying we must find all three currents. So here is a junction, right? So this junction has IA going out and IB going out and IC going in. Therefore, our first law, our first Kirchhoff law, which basically states that the sum of the currents flowing into any point is equal to the sum of the currents flowing out. Hence, the first equation using the first law will be IA plus IB is equal to IC, because of course, as we can see here, IC is going in and IA and IB is coming out. So IA plus IB will give IC, right? So our second equation using the voltage law, right? So I'm just going to choose any direction for my loop in these circuits. So I normally just go like this, go like this, right? So let us look on this one, the top one first, right? Okay, so of course I normally start from the battery, and I'm going from negative to positive, so that's 9 volts, and this current and this voltage is gonna give me another voltage. So this current is going in the opposite direction from my loop. Therefore, this will result in a voltage rise. So I'm going to get positive 0.012 IB. And then this current IA is going in the same direction as my loop. Therefore, this is going to result in a voltage drop. So negative I1 IA. So that's how I normally get the positive and the negative, right? And then all of this comes back right here, equals to 0. Then our third equation is looking at down here, this circuit, this part of the circuit. So of course, as usual, I start from battery. I'm going in this direction. So but literally looking at the battery, I'm going from negative to positive, so that's going to give me a positive 12 volts. This current is going in the same direction as my loop, hence I'm going to get a voltage drop, so that's negative 0.15 IC. And then coming up here, this current is going in the same direction as my loop, so also another voltage drop. And coming to this battery now, it's going from positive to negative. So the positive to the negative end of the terminal is going to give me a negative 9 volts. And so there I have my 3 equations, which is perfect. So wherever, as usual, I see IC, I'm going to substitute it with IA plus IB, which I can, right? Because the IA plus IB is equal to IC. So let's just get to it. Okay, great. So let's look on this first one with when we use the first loop. So there is no IC in it, so I'm going to just leave that equation alone and just concentrate on this one, and there's IC in it. So let me just substitute. So this would have been 12 minus 0.15 IA plus IB minus 0.012 IB minus 9 equals 0. 12 minus 0.15 IE minus 0.15 IB minus 0.012 IB minus 9 equals 0, right? And of course, as usual, when we're here, we group like terms. So here is 12, here is negative 9, so 12 minus 9. IA is a lone soldier, so I'll just put it back. Nothing to group it with. Then here are two IBs, so that would have been okay. So 12 minus 9 is 3. Put back our IE and then negative 0.15 minus 0.012 is going to give me negative 0.162 IB. Okay, so great. So actually we can put this into a nice equation right here. So of course I like to put my IEs first, so it would be 0.15 IE and 0.162 IB. Then carrying over the positive 3 is going to give me negative 3, right? Okay. Okay, so following, we're going to put this equation like a normal equation. So let's just start here. Negative 1.1 IA plus 0.012 IB, and then the positive 9 we carry over as a negative 9, right? So this was for our first loop. And then our second loop, the normal equation that we had gotten was this. So I can just write it back. So this was negative 0.15 IE minus 0.162 IB equals negative 3, right? So of course, this is a bit of a weirdish looking equation because normally they don't give decimals. So in this case, as usual, I look for the smallest numbers or the most digestible numbers, if you want to call it that. These look the best to use. So what I would do, I would just divide the 0.162 by this number to find a common factor, right? And turns out that if you divide 0.162 by 0.012, the common factor is 13.5, right? So if I times 0.012 by 13.5, it would give me 0.162. And of course, getting back this, I could just times it by 1 to get back 0.162. But it would, since this is negative, it would give me a negative 0.162. So great. So now we can actually solve simultaneously. We're going to multiply the first equation, all of it, by 13.5, and then all of the second equation by 1. So here we go. So negative 1.1 times 13.5 is going to give me negative 14.85 IA, and then this by 13.5, and I've gotten positive 0.162 IB. Then negative 9 times 0.162 gives where that negative 121.5, right? And times in the second equation by just 1 is the best thing. I'm gonna give back just the same values. Great, so now we can solve simultaneously. So we're going to add the equations to solve simultaneously. So negative 14.85 plus negative 0.15 is going to give us a negative 15 IA. This is going to give 0, so we can just cross that out really. And then this is going to be negative 121.5 minus 3 is going to give negative 124.5. Hence, IA is going to be negative 124.5 divided by negative 15, which is going to be 8.3 amps. Great. So, of course, as usual, once we have one current, that's the best thing, because we can just substitute it to find IB, right? Which equation? You can use anyone. Of course, I normally just prefer just anything that seems a bit less. So, well, today I'm just going to use a random one. I'm going to use the top one. So, negative 1.1, 8.3 plus 0.012. This multiplying this gives negative 9.13 plus 0.012 IB equals to negative 9. Of course, we carry this negative 9.13 over the equal sign, giving you a positive 9.13, which equals to 0.13. Right. Therefore, now IB is going to be 0.13 divided by 0.012, which is going to be 0. Let's work that out. So it's going to be 10.81, right? 10.81 amps. So that's IB. And of course, we had said initially that IC is equal to IA plus IB. Therefore, since IA plus IB equals IC, IA, and we know that IA is 8.3 amps and IB is 10.81 amps. Simply add that up, and that gives us, just see, 19.11 amps. Okay, and so that's how you would do number 19. So I hope you understood that.